Hi, I'm Kenny Lee. Let's talk a little bit about speed and velocity. So, for speed, what does the definition of speed bring to mind if you were to think about that word? Now, if you were Webster, you would come up with something that looks like this, that speed is the rate at which an object's position changes. And that's a perfectly accurate definition. Only problem is if you didn't already know what the word means, that may not help you. So let's come up with a common definition for speed. And I believe something like how fast the object is traveling is pretty close. We kind of know what speed is. Well, there's another word that's very similar to speed, but there is a little bit of a difference, and that's velocity. Now, for velocity, it's like speed, but it has something extra. It's a vector. So that means it also has direction. So if we go back to Webster, the definition will change by just a little bit. It will still have the rate at which an object's position changes, but it'll also add in a certain direction. So we've added that to it. Where speed's a scalar, velocity's a vector. So that means our common definition will also add in the direction component. How fast an object will travel in a certain direction. So if you're asked in one word, what's the difference between speed and velocity? That one word should be direction. Velocity has it, speed doesn't. So now that we got the difference in the two terms, what can we do? Well, one thing that we can do is we can actually find the average speed or velocity of an object. And a good way to think about the average velocity is the overall for the entire trip. And when you find average velocity, it's just not taking two numbers, adding them together and dividing by two. That won't always work. If we take something like, let's say I'm driving a car 10 meters per second for an hour, or let's make it better. Let's say 10 miles an hour for an hour. Then I speed up and go 20 miles per hour for an hour. My average speed should be around 15 miles an hour. But if we do the same thing, except we change this, I drive 10 miles an hour for 1 hour, but drive 20 miles per hour for just 10 minutes, you wouldn't expect the average speed to be 15 miles per hour like it was in the last example, because we didn't travel 20 miles per hour, but for a short amount of time. And so that's going to pull the average down closer to 10. If we have driven 20 miles per hour for maybe 4 hours and 10 miles an hour for just 1 hour, that will pull the average up to a higher number, closer to 20. And so we have to take into account how long we're at a certain speed. So one way we can do that will always works if we can always take the total distance divided by the total time. So for average velocity, take the total distance, everything added together, and the total time, how long it took for the entire trip. That will always give you the average speed or average velocity for the entire trip. So for us, our normal unit for velocity is going to be meters per second. Distance in meters, times in seconds, if we're keeping to the standard SI unit system. So always take that total distance divided by total time. Another term that we can talk about is instantaneous velocity or instantaneous speed. And that's simply how fast you're going at that moment. It's precise, like right then, how fast are you going? And so to designate that in an equation, where here we just have a V, that no subscripts, nothing to it, just a V. Sometimes you may see it in textbooks, it's got a bar across the top of it. That stands for average. But if that V had a subscript, like a VF or a VO, VF is usually final velocity, VO is usually original velocity. That would make it an instantaneous speed or velocity. Without that, we're going to consider it an average. So let's look at some questions about speed and velocity and see what we can answer. So I've already talked about that one without the subscripts, meaning that's an instantaneous speed or velocity. And if it doesn't, it's just an average. But here's some questions. On the side of the road, we get all these signs that are white. They have 25, 65, 70 written on them. What do we call those? Well, we call them speed limit signs. And we actually named it correctly. We're talking about speed, not velocity. Okay. If it was a velocity limit sign, then you could go 70 miles per hour north. Well, if the road changed directions, you're out of luck because you still had to go north. We call them speed limit signs because we don't care about which direction you're going. It's better that you follow the road. That's nice. But it doesn't really matter which way you're going as long as you limit yourself to that speed. Another thing is if you're walking around a track, can you walk around the track at a constant speed? I can say, yeah. Basically, you can keep your same pace all the way through there, so you walk around the track at a constant speed. But could you walk around a track at a constant velocity? That one's not going to work out because as you round the curves, you're changing your direction. You may keep the speed the same, but you're changing direction, so that means you're changing your velocity. Another thing that we actually name right is that device on your car that tells you how fast you're going. It's called a speedometer, a speedometer. And what does that speedometer tell you? Well, it tells you the instantaneous speed of your car. It'd be quite useless if it told you the average. You would never know exactly how fast you were going at that moment just for the entire trip. And going back to those speed limit signs, are they talking about your average speed or your instantaneous speed? Let's talking about your instantaneous speed. So if you get pulled over and the officer says, well, Mr. Lee, we caught you doing 30 in a 20 mile per hour zone, you can't go, but officer, I was parked back there, so that's 0. I was doing 30 here, so 30 plus 0 divided by 2, 15 miles per hour. I'm actually going 5 under. Actually going 5 under. Well, that probably won't work. Okay, because they're concerned about your instantaneous speed, not your average speed. If we have two students walking towards each other at a rate of 2 meters per second, then they would have the same speed, but not the same velocity. If they were going in the same direction, they would have the same speed, the same magnitude, and the same direction, so they would have the same velocity. Because remember, velocity is both speed and direction. So if you've got the same velocity, you automatically have the same speed. But if we have two things that have the same speed, that doesn't necessarily mean that they have the same velocity. They could be going in different directions. Thank you, and talk to you later in another video. Goodbye.